and GNS3 is there. So topology is different for today. See guys, same topology, we have EIGRP here, then OSPF area 0, then OSPF area 1, and we can extend the topology according to our requirement here. Again, you can say OSPF area 0 is the headquarter, EIGRP is my partner network, right? Let's say I have merged the network to two company network. Then OSPF area 1 is, let's say, my branch office, branch 1. Like that this we can connect more branches as well. Done. So we are not going to spend time to understand the topology because the topology is simple, and I think you all are familiar with this type of topology. Now before starting the session, let me ask you one question. That I have three router, R1, R2, R3, R4. If you are thinking why I'm connecting four router together, this can be a question, and you guys should ask this type of question. Why you are connecting four router in series full? Yes or no? Like this. Don't worry. At the end, at the end of this course, you will have clear and crystal understanding of these all types of design. Whatever design I am talking guys in the live class, all are real-time scenarios. R3, R4, R5. Here we have one LAN local area network connected with router number 1. Here I have one LAN connected with router number 5. And let's suppose here as well, like we have one LAN connected with all switches, sorry, all routers R1, R2, R3, R4. We have one LAN over here, we have one LAN over here. One LAN is connected with router 2, one LAN is connected with 3, one with 4. Here subnet is 10.1.1.0/24. Here the subnet is 50.1.1.0/24. Then now let's suppose we have some devices in area 1. These routers belongs to area 1, and this router belongs to area, which area? OSPF area 1, OSPF area 2. Now my question to you is this. Tell me, can 10 users communicate with 50 users? Can 10 users communicate with 50 users? If no, then tell me the reason why. So correct. But why? What will happen if R3 is not the ABR? What is the issue here? Tell me the issue now. Why router 1 cannot communicate with router 5, or these LAN users cannot communicate with these LAN users? What is the reason here? I am agree with you that router 3 is not ABR router. I am agree. But the issue, what is the issue? Hmm, correct. This is the answer. This would be your answer. That LSA 1 of router 1 cannot reach to router 5. In the same way, LSA 1 of router 5 cannot reach to router 1, right? This is the reason router 1 will not have route for 50 networks, and router 5 will not have route 4 10 network. Now tell me, if I want to make communication possible between this network and this network, what should I do here? How to make communication? How to make communication? Problem is, guys, all routers are going to create their LSA 1, and in their LSA 1, all routers are going to install their link information, link state information, and router 3 is going to create two number of LSA 1, one for area 1 and one for area 2, right? So router 3 will have three number of LSA in area 2, 3.3.3.3, 4.4.4.4, 5.5.5.5. In the same way, router 3 will have three number of LSA 1 in area 1, 1.1.1.1, 2.2.2.2, and 3.3.3.3, right? In this LSA 1 of router 1, there is information of this 10 network, correct guys? In the same way, in the LSA 1 of router 5, there is information of this network, correct? But LSA 1 cannot cross the area, means router 2 and router 1 will not have the LSA 1 of router 5. In the same way, router 4 and router 5 will not have the LSA 1 of router 1. Will there any LSA 2 guys in this scenario? Is any router is going to generate LSA 2? No, there is no DR and BDR, right? Network type over here is P2P, point to point, right? So there is no DR and BDR. Even on this interface, if you are thinking Praful, on this interface network type is broadcast, so we will have DR. But as you know, to stop routing protocol messages on LAN interface, you are going to configure that interface as passive, right? So there will be no LSA 2, right? And for inter-area communication, LSA 3 is required. And who will generate LSA 3? ABR router. But the issue is there is no any ABR router. Now I want to make communication possible between these two areas. How I can make router number 3 as ABR router? See, can I create one loopback here? If I will create one loopback here, let's say IP address is 3.3.3.3, and if I will advertise that loopback in area 0, then what will happen, guys? What will happen then? Now tell me, can these two users communicate? Yes. Because once you will advertise one interface in area 0, router will become what? ABR router. But this is not the way which we are using, right, in the real time. Okay, for now, let's suppose router 3 is ABR router. Then now router 3 is going to generate LSA 3. How many number of LSA 3 router 3 will generate? How many LSA 3 router 3 will generate? Two. No. Incorrect answer. No. 3, 4. Which area? See, first of all, tell me how many subnets are there in area 1? 1, 2, and 3. So router 3 is going to advertise these 3 subnet in area 2. And these 3, this subnet, and this subnet in area 1. Right? So router 3, as router 3 is ABR router, it will generate 3 number of LSA 3 for area 1 and 3 number of LSA 3 for area 2. we have covered these all concept in last class guys, in yesterday class, and today we are going to understand the areas concept. Before talking about the areas concept, I would like to ask you the LSAs. Like, we have covered LSA1. LSA1 is router LSA. We have covered LSA2, that is network LSA. LSA3 summary LSA. Summary LSA. LSA4 is what? LSA4 summary ABR LSA. And LSA5 external LSA, right? External LSA. Now which router will generate router LSA? All router in the OSPF domain. Which router will generate network LSA? DR router. Which router will generate LSA3? ABR router. Which router will generate LSA4? Summary ABR LSA. Hello. Again ABR, right? Which router will generate external LSA, LSA5? ESBR, right? What is the use of router LSA? To share link state information. What is the use of network LSA? To share attached router in the segment. What is the use of summary LSA? Summary LSA to share inter area prefixes. What is the use of summary ABR LSA, guys? For sharing the information of ESBR router. Where is the ESBR router? Because a router in OSPF domain can identify the ABR router. Who is ABR? With the help of B bit, right? But router cannot identify ESBR if router belongs to different area, like in this scenario. In this scenario, which router is ESBR router? Router 3 and router 4. So these two routers will on E bit in their LSA1, and their LSA1 will flood within area. Means router 1 can get to know about the ESBR, router 5 can get to know about the ESBR, router 6, router 7 can get to know about the ESBR, but how router 8 will get to know about the ESBR? Because LSA1 of router 3 and 4 cannot cross the area, right? Means LSA1 will not enter in area 1. So that's why EBR router will generate LSA4. Who is the EBR? Router number 6 and router number 7, C, are connected with area 0 and area 1. So these two routers are going to generate what? LSA4. LSA4 to share the information of ESBR. So with the help of LSA4, router 8 will came to know about the ESBR router. The router 3 and router 4 are my ESBR router. Done. Then LSA5. Which router will generate LSA5? ESBR router. To share external network information. Like in this scenario, router 3 as well as router 4. Both routers are going to generate what? LSA5. Right? Now we have one more LSA. That is LSA7. And LSA7 is NSSA LSA. Right? So today we will see this LSA, NSSA, LSA. What is the use of it? And guys, whenever we will redistribute external route in EIGRP, like you can see router 3 and router 4 are going to redistribute EIGRP route into OSPF, right? So redistributed route in OSPF domain can enter with two types of cost. External route can enter in OSPF domain with two different types of cost. if I will talk about that cost, so let me say that is metric for external route, metric for internal route. You all know how OSPF is going to calculate cost. Within the area, it is going to find directly cost by using the reference bandwidth and bandwidth of link. Between the area, like you can see, router 1 is advertising these all networks to router 6, router 7. These routers are going to calculate cost. But how router 8 is going to calculate cost for these prefixes? By adding cost to reach ABR, because ABR, both ABR are going to advertise this route with some metric, right? Let's say both are advertising this route with metric 10, right? So router knows that ABR router is advertising these prefixes with metric 10, and router 8 knows what is the metric to reach ABR router. So it will add the metric, right? So if metric to reach ABR router is 5, so total cost to reach in this network is 15. This is how router 8 is going to calculate metric. Now, how router 8 is going to calculate metric for these external prefixes, or how these are router 5, router 1, router 6, router 7, these routers are going to calculate metric for external prefixes. So we have two options, two types of metric. While redistribution, either EIGRP can redistribute, sorry, router 3 can redistribute EIGRP into OSPF with metric E1 or E2. By default is E2. By default, ESBR advertise external prefixes in OSPF domain with metric type 2, right? So we have two types of metric for external prefixes in OSPF. First one is type 1, which is E1, and second one is type 2, which is E2. And by default, router uses type 2, that is E2. And whenever routers will advertise external prefixes in OSPF, or you can say whenever ESBR will advertise external prefixes in OSPF with metric type 2, means with E2, routers are not going to add metric to reach ESBR. Let's say router 3 is advertising these 20 networks with metric type E2 and metric is 10. That means all routers in OSPF domain are going to use same metric for the destination network, right? Metric on router number 1 will be also 10, metric on router number 5 will be also 10, metric on router 6 and 7 will be also 10. So E2 type 2 metric for external route is metric from ESBR to the destination network. Router uses metric from ESBR to the external network. Router does not use total metric to reach destination. But if we will configure E1, then routers are going to use total metric. Like then router 1 will add metric to reach ESBR. Router 1 will receive these network external prefixes in the form of LSA 5, and ESBR will share metric with route. So let's say with 20 network, it is sending metric what 5, and router 1 is going to add the metric to reach ESBR. Let's say metric to reach ESBR is 1. So total metric to reach destination is 6. But if ESBR is redistributing with type 2 metric, then router 1 will not add metric to reach ESBR, right? So what we can say if ESBR router is redistributing external prefixes in OSPF with metric type 2, then routers are not going to use total metric from source to destination. Then routers in the OSPF domain will use metric from ESBR to the destination, and that metric is called SID metric. That metric is called SID metric. Got it? That metric is called, guys, SID metric. Let me do one thing. Let me configure this scenario. I think this scenario is already configured. Let me access it. Yeah, R1. R1, R3, and R4. On R1, so IP protocol. Which protocol is running? OSPF 1, right? And I am perform routing for all the interfaces, right? All interfaces are advertising OSPF area 0. So IP OSPF interface brief, even we can use this command. So IP OSPF interface brief, you can see OSPF is enabled on all interfaces, and all interfaces are in area 0, correct? We have OSPF neighborship. Now you can see, so IP OSPF neighbor. So 3.3.3 and 4.4.4. I think this topology is configured. This topology is configured, and these routers are not configured. We'll do the configuration of these devices later. Done. Now let me take you to R3 and R4 on the ESBR routers. So IP route OSPF. See, router 3 is learning all the subnet connected with router number 1. In the same way, router 4, so IP route OSPF, router 4 is also learning all connected network on router number 1. Now on R3, so IP route EIGRP. So there is no any route from the EIGRP, so IP EIGRP interface. EIGRP is not enabled on router number 3, so IP protocol OSPF is running and BGP is running. BGP is number 100. Actually earlier I was using this topology in BGP class, right? So let me do one thing, let me replace the configuration. So run section OSPF, let me check the commands in OSPF. Done. On router number 4, so IP, so run section OSPF. Done. Basic configuration, right? Now so run section BGP. So we have BGP configuration here. Let me remove the BGP configuration. Say no router BGP AS number 100 and router EIGRP AS number 10 and network 23.1.1.0. say no auto summary. Now let me save the configuration. Now you can see we have EIGRP neighborship. So IP EIGRP neighbor. Done. Who is the neighbor? Router number 2. And so IP route EIGRP. Now you can see router 3 is learning all connected networks to router 2. Done. In the same way on router number 4, config T router EIGRP AS number 10 and network. What network? 24.1.1.0. say no auto summary. So IP route EIGRP. So IP route. So IP route EIGRP. Done. Both routers are learning route from EIGRP as well as from OSPF. Now guys, we need to redistribute EIGRP into OSPF. So let me take you to R3 first. And here, while redistribution, router OSPF process ID 1 and say redistribute EIGRP as number 10. See, if you will hit enter over here, right, like this, then first of all, only class full networks will be redistributed. If you want to redistribute classless networks also, so you have to use one keyword here, that is subnet, right? Again, if I am running command like this, then metric type will be what? Type 2. Default metric type for external prefixes, type 2. If you want to change the type to metric, you will run command redistribute EIGRP AS number 10 subnet and then metric type. Metric type is type 1 or type 2. It can be type 1 or it can be type 2. By default, metric type is type 2. And now I can say type 2 and then metric. If you want to define any metric here. If you will not define the metric, then it will use SID metric, right, which is 20 by default, which is 20 by default. So now I am not going to use these keywords here. I am saying redistribute EIGRPS number 10 subnet only, right? On the router number 4 also, router OSPF process 1 and say redistribute EIGRPS number 10 subnet. Done. I have redistributed. So IP protocol. Now this router is ASBR router, area border router, sorry, autonomous system border router. It is an autonomous system border router, ASBR. So if this router is not ASBR, then this router is going to generate LSA 5. So IP OSPF database. So you can see the LSA 5. How many LSA 5 are there? How many LSA 5 are there, guys? 1, 2, 3, 4, 5. Router 3 is generating 5 number of LSA 5, as well as router 4 is generating 5 number of LSA 5. Why 5 LSA? Because we have 5 number of subnets in EIGRP domain, right? 3, 4, 5. Done. For each subnet, ESBR will generate LSA 5. And see, router 4 is learning all LSA from their neighbor as well, like this, right? Router 3 is advertising LSA 5 to router 1, LSA 5, and then router 1 is advertising it to router 4, LSA 5. So that's why you can see we have LSA 5 from 4.4.4 also, and from 3.3.3 also. Clear? Any question, guys? Both routers are generating LSA 5, and see, once I have redistributed EIGRP into OSPF on router 3 and router 4, both routers are going to generate LSA 5. LSA 5. Both will advertise to their neighbor. Now whatever LSA 5 router 1 will receive from router number 5, router number 4 from their neighbor, it will advertise to their other neighbor as well, means to router number 3 and router number 5, correct? So that's why here in the database of router 3 you will see LSA 5 of router 3 as well as LSA 5 of router 4. Done. Any other question? Yeah, metric E2. Now how to verify that? Metric E2 or E1? So let me do one thing. Let me take you to, let's say, R1. And on R1, so IP route OSPF. Are you able to see external prefixes? External prefixes. And this E2 means metric 2. E1 means metric type 1. So IP route, here you can check these values. E2, wait bro, wait, yes, E2 is OSPF external type 2. E1 is OSPF external type 1. And as we are advertising, we are redistributing external prefixes in OSPF with metric type 2. You can see metric is 20, which is SID metric, and actually ASBR router is advertising this route with same metric. So IP OSPF database, then external and external LSA of Any router you can check, like you can see 3.3 and 4.4, both routers are advertising external LSA. So if I will open this LSA in detail, so IP-OSPF database external and then 20.1.1.0, see the metric over here, metric is 20. That means ESBR is advertising external prefixes with metric 20, and same metric router is using. It is not adding metric to reach ESBR. So IP OSPF border router, you can see metric to reach ESBR is 1. So if you will change the metric type, then metric will become what? 21. 20 is coming in the LSA and 1 is the metric to reach ESBR, who is advertising this LSA. Got it? There is forwarded address, we will discuss this also. External route tag, tag is similar like the tag in EIGRP, which we had discussed. Yes, question guys, question. Just 1 minute guys. Yes, by default SID metric is 20. So OSPF always redistribute external prefixes in OSPF domain with metric 20. But if you want to change it, simply I can say what? Metric. Let's say I want to perform now load balancing between these two ASPR, right? So here I can say what? I will advertise external prefixes with metric 20, or here I can increase the metric 21. Now router will install one path. Right now you can see maybe router 1 is performing load balancing on R1. If I will check, so IP route OSPF, it is performing load balancing, yes or no, between both ESBR. Correct guys? Because it is getting external prefixes with same metric, right? So this is the path manipulation. See, on router number 1 I can say metric 21. Now again go to router number 1 and check the routing table. See, now it is not performing load balancing, right? All routes are best via router 4. Reason, so IP OSPF database, so IP OSPF database, and then we can say external 20.1.1.0. Who is advertising? Advertising router ID 3.3.3, router 3, with what metric? 21. This time who is advertising? 4.4.4, with what metric? 20. Correct. So we can manipulate the path with the help of metric. This is the first option for the path manipulation in OSPF. Yes, question. Can anyone check what is the command to check seed metric on router? I'm going to remove this command, guys, for now. See, there are many options for path manipulation here. Even I can change the metric type, and metric type 1 is more preferable over metric type 2. If I will talk about the path manipulation in OSPF, see guys, let's suppose, very important, I have router 1, and then this router is connected with, let's say, 2 ISP1 and ISP2. Best path selection in OSPF. Or router 1 is connected with two different companies network, company 1 and company 2, R1, right? Both companies are advertising external prefixes, which is 10.1.1.0/24, and this company is also advertising same network, 10.1.1.0/24. Here I am running OSPF. This is my OSPF domain, OSPF. And on the internet or in the different company, we are running any other routing protocol. Let's suppose BGP. So both is ESBR routers are going to advertise this network, right? 10.1.1.0 network to router number 1. By default, both will advertise with metric type 2. Both are advertising with metric type 2. Now let's say this is my primary link. This is my primary path. This is the backup path. Backup path. Here bandwidth is 10 Gbps. Here bandwidth is 1 Gbps. Here bandwidth is 1 Gbps. So tell me, router 1 is going to install external 10.1.1.0 network via which path? Via ISP1 or ISP2. Let's say this is ISP1, this is ISP2. Router 1 will install this network 10 network in their routing table via which path, or it will perform load balancing, guys. Here let's say OSPF metric is, here OSPF metric is 2, here OSPF metric is 10. Yes, tell me. Yeah, so tell me, router R1 will perform load balancing or not? What others, guys? But by default, what I am saying, that router 1 is not going to add metric to reach ESBR, na? So both routers are advertising 10 network with seed metric, which is 20, right? Router 1 is going to perform load balancing, brother, here. If you want that router should not perform load balancing, here you have to change what? Metric type. If you will set metric type E1, then router is going to calculate total metric, right? So let's say here we are advertising external route with metric 20. Here also we are advertising with metric 20. Now from this path metric will be 22. From this path metric will be 30. So this time router will not perform load balancing, but by default router will perform load balancing. Getting my point? Is it clear? By default router will perform load balancing. Guys, if I will talk about the best path selection in OSPF, so see, first of all, we have different types of route in OSPF. For inter-area prefixes, routers are going to denote prefix with symbol O. For inter-area prefixes, OIA. For external prefixes, E1 or E2. And then you will see we have some more types of prefixes. So always keep in mind, intra-area prefixes is always prefer over inter-area prefixes, right? Then inter-area prefixes is always prefer our external prefixes E1, and E1 is always prefer our E2. So the other option for path manipulation, I want to make this path as a best path. So here I will redistribute external prefixes with matrix type 1, here matrix type 2. Now whatever prefixes these orders are going to advertise in OSPF domain, best path will be always via ISP1. Best path will be via always ISP1. Yes or no? Yes or no, guys? Yes. Right. So these matrix types or the seed matrix concept, these are very useful for path manipulation and for real-time scenarios. Right. These are the only, concepts of OSPF, good concepts of OSPF. And this is the reason only we are using OSPF everywhere nowadays. Like in my, hope now it's fine. Now in the my company, let's say this is pmnet.com, headquarter of pmnet.com, guys, and this is any other company, XYZ company. XYZ company is advertising 10,000 routes in the OSPF domain, but I always want to install all 10,000 prefixes in OSPF in the headquarter via router number 3. Simply I can configure, I can redistribute external prefixes with matrix type E1, here E2. Got it? Can you check what is the command to check seed matrix? Just Google it. So IP OSPF, let me check. Is there any information, guys, about the seed matrix? Hey, can anyone tell me what is the command to check seed matrix? One command is simply we can open database in detail. So IP OSPF database, in the database we have some external LSAs, so we can open that LSA in detail. On router number 3 also you can see now we don't have LSA 5 of router 3. Router 3. In the database of router 3 you can see LSA 5 of router 4. The reason, router 3 is also generating LSA 5 but with matrix 21. So that's why even router 3 is going to learn these networks in OSPF via router 1, like this. So now I can open any LSA in detail. So IP OSPF database external and 20.1.1.0. Here we can see the seed matrix. Seed matrix is 20. But there is one another command as well to check the seed matrix. You can check it and you can let me know as well. And you know how to change the seed matrix? Router OSPF process 1 and redistribute EIGRP AS number 10 subnet. These are the compulsory keyword to redistribute route in OSPF, and then I can define the matrix, right? So here I had changed the matrix. Let me set matrix 10 again, 20 again, right? Again router 1 will start performing load balancing here. So IP route OSPF, you can see it is performing load balancing. Now I want to receive external prefixes in OSPF from router number 3 always. So simply I can change the matrix type. So router OSPF 1 redistribute EIGRP as number 10 subnet and matrix type. Matrix type is 1. Now again go to router number 1 and so IP route OSPF. You can see all networks are based via router number 3. So IP OSPF database. In the database, see the external LSAs. Router 1 is learning external LSA from both ASBR, from 3.3.3 also and from 4.4.4 also. Now I want to open it in detail. So IP OSPF database external and 20.1.1.0. See the output. Who is advertising? 3.3.3 and metric type is 1. And when 4.4.4 is advertising, guys, when advertising router ID is 4.4.4, that time metric type is 2. Metric type 1 comparable directly to link state metric, means total metric from R1 to destination, and metric type 2 means metric from ASBR to destination larger than any link state path. Like the actual concept of type 1 and type 2 in real time is, see, let's say here this is your primary link and this is your secondary link, right? Or you have two different link here. Let's say here bandwidth is 100 Mbps, here bandwidth is 10 Mbps. But for external prefixes, you want to behave both link as a same. That time you should use what? Metric type E2. Got it? Means for external prefixes, my internal OSPF metric doesn't matter. My internal OSPF cost doesn't matter. Right? For this link also, for this link also, doesn't matter. This link also. Done, guys? Clear, guys? So here we have two concepts. Either we can change the metric type for the path manipulation, or I can configure higher metric. I can change the seed metric. What other options we have while redistribution? Router OSPF process 1 say redistribute EIGRP AS number 10 subnet compulsory command, and then metric type is 2, and then we can define metric, let's say 10. Then okay, this is order 1. Let me thank you, brother. On order number 3, metric type 1, then I can define metric, and after that again I can call to metric type, I can call to route map, right? And you already know the route map. In the route map I can filter the route, I can add the tag value, I can match the metric. So let's suppose I want to redistribute only a specific external prefixes, let's say who have metric 10, so I can use route map. Even I can add the tag number here, tag. Got it, guys? So we have these all options: route map, Cisco. We will see the redistribution later. For now, let me again come to our topic, that is OSPF LSA 7, next LSA. Done. So hope LSA 1 to LSA 5, all LSAs are clear and crystal to everyone. Yes or no? Yes or no, guys? Yes? If yes, then tell me, I will move. On order number 1, do so IP OSPF database. We have LSA 1, we have LSA 2. Why we have LSA 2? Then we have LSA 5. But here LSA 2 is not required. Simply what I will do, interface F0/0, F0/0, say IP OSPF network what? Point to point. Interface F 1/0 IP OSPF network point to point. On router number 3 also interface F0/0 IP OSPF network point to point. On router number 4 interface F0/0 IP OSPF network point to point, and do so run section OSPF. Redistribute EIGRP10 subnet. Same command I am going to use on router number 3 also, so that it should perform. It should redistribute external prefixes with default SID metric, which is 20, and with default metric type. Do so run section OSPF. I'm going to remove this command. Now you can see router 1 is not performing load balancing, so IP route OSPF not performing load balancing. All are reachable via router number 3 only. The reason, metric type. So let me say no to this command, no to this, no to this command. Redistribute EIGRP AS number 10. What happened? No. Okay. Router OSPF 1, and then no to this command. Then redistribute EIGRP AS number 10 and subnet. That's it. Now save the configuration of router 3, save the configuration of router 4. Go to router number 1 and check again it is performing load balancing or not. So yes, it is performing now load balancing. Done. Now let me configure rest scenario. Here interface, and before configuring F0/1, do so IP OSPF database. Now let me check LSA2 is filtered or not. Yes, now you can see we have LSA1 and LSA5 only. Correct, guys? In the database of router 1, we have only two types of LSAs, LSA1 and LSA5. Now let me configure interface F0/1, say no set here, and IP address between router 1 and router 5, 15.1.1.1, 255.255.255.0. IP OSPF network point to point, and IP OSPF 1 area 0. I am going to advertise it in area 0 only. Then let me access R5, router 5. Config T, interface F0/0, IP address 15.1.1.5, 255.255.255.0, say no such, and IP OSPF network point to point, and IP OSPF 1 area 0. So IP OSPF neighborship is in the access start state, now in full. So IP route OSPF. So you can see we have some intra area prefix, we have some external prefixes. Done. Now let me configure REST2 interface as well. Here interface F1/0 and say no set, and IP address. IP address between router 5 and router 6, 56.1.1.5, 255.255.255.0, no such, IP OSPF network point to point, and IP OSPF 1 area 0 exit interface. And here I should configure the router ID as well, router OSPF 1 and router ID 5.5.5.5. Can I change router ID? No, I am not able to change the router ID. What I can do, guys? What I can do? I have to clear the OSPF process. Why you are not able to change router ID? Because router 5 have already shared their database with their neighbor, means with router number 1. So say do clear IP OSPF process and say yes to this, and now you can change the router ID before forming neighborship. Done. Now interface F1/1, say no set, and IP address between router 5 and router 7. Yeah, router 7. I'm going to use 57.1.1.5.255.255.0 IP OSPF network point 2 point and IP OSPF 1 area 0. Done. So IP OSPF interface brief. You can see OSPF is enabled on all interfaces and all interfaces are in area 0. Let me write the configuration. Let me access router 6 and router 7. Now these two routers are going to become what? ABR. Right guys? So see, on the ABR as well we can perform what? Path manipulation. Even I can perform load balancing between multiple ABR. Like ASBR. On ASBR we have what options? We have the metric option. We can change the metric, right? We can use metric type. Then we have route map. We will see the route map option later. Then interface. For the path manipulation in OSPF we have multiple options guys. Let me write here. For the path manipulation in OSPF we can use cost. In EIGRP also we have multiple options like variance, offset list, k values. In the same way in OSPF we have cost, we have reference bandwidth, then we have summarization. We will see it later, don't worry. We have area we can use area concept as well. Then redistribution, while redistribution also we can perform path manipulation. Then distance value we have distance value. Then PBR also we can use policy based routing. Now you don't know the PBR, later we will see PBR as well. Done. So these are the options for path manipulation in OSPF. See the distance, like here right now R1 is performing load balancing, right? So IP OSPF route, so IP route OSPF. Done, it is performing load balancing. Another option is, let's say I want to receive all external prefixes via router number 3 only. So here I can configure lower distance. By default distance from both sides is 110. But here I can set distance what? 100. So once you will configure distance 100 on router number 3, what will happen? Router 3 will advertise all external prefixes with AD value 100 and router 4 will advertise all external prefixes with AD value 110. So automatically upper path will become the best path. If you want to configure it, simply on router number 3 we can say router OSPF 1 and distance 100. That's it. Now go to router number 1 and see the routing table. Distance from both sides is still 110. Clear IP OSPF process, say yes. See, OSPF neighborship is coming in forwarding state quickly. This is just because of network type. So IP route OSPF. Still, it is performing load balancing for all external prefixes. Right? Don't worry, we will see it guys. Distance over here is 100. Simply you can execute command show IP protocol. So the distance, default distance is now 100. Clear IP OSPF process. Let me write this command here once. So IP route OSPF. See what is happening? Actually router 3 router 3 is using AD value 100 for all the prefixes. So here I am going to remove that command, router OSPF 1 and distance 100. Let me say no to this, and so IP protocol again. This time distance is again 110, and so IP route OSPF again distance is fine 110. Now go to R1 and say router OSPF 1 and distance 100, and then source. For which source? So I can say for R3. Whenever you will receive traffic from R3, that time set so distance what? 100. We can perform path manipulation like this by using distance value. Don't worry, we will see these all things. Let me take you to router 6 now, and on router number 6 go to interface f1/0 and say no cert, and the IP address 56.1.1.6.255.255.255.0. exit interface f0/0 no cert, and the IP address is between router 6 and router 8 68.1.1.6.255.255.255.0. router OSPF 1 and router ID 6.6.6.6. Now guys, here I am going to advertise one interface in area 0 f1/0 IP OSPF network point 2 point and IP OSPF 1 area 0. Then interface f0/0 IP OSPF network point to point and IP OSPF 1 area. Which area it is? Area 1. Now this router will become what? ABR. So IP protocol. This router is my area border router. So IP OSPF database. See, we have external LSAs or not, guys? Yes, we have all external LSAs. Who is advertising? ASBR router 3 and router 4. So LSA 5 can cross area, no problem at all. Right? Then the router LSA in area 0, and this is summary LSA, means LSA 3 for area 0. So in area 0, router is advertising this subnet which is running over here, right? Later on, ABR router, this ABR router is going to generate 4 LSA, 3 LSA, 2, 3 and 1 over here on this link. So total 4 LSAs, 3. Done. Now in the same way, let me configure router 7, and on router number 7, config T interface f1/0 say no cert and IP address. What will be IP here? 57, I think, right? IP OSPF network point to point exit interface f1/1 IP OSPF network point to point IP address. On 1/1 IP address is going to be 78. Yes, 78.1.1.7 255 255.255.0. Done. Router OSPF 1 and router ID 7.7.7.7. exit interface range f1/0 and f0/0 or 1/1. IP OSPF 1, not both interfaces are in same area. Let me correct it. Interface f1/0 IP OSPF 1 area 0 and 1/1 is in area 1. IP OSPF 1 area 1. Now this router will also become what? ABR. So how many ABR are there, guys, in my networks? Now we have 2 ABR. Why this router is not ABR router? So IP OSPF interface brief. This interface is in area 0, this interface is in area 1. Here state is done. So IP interface brief exclude unassign. This interface is manually shut down. So interface f1/1 say no set. Write the configuration. Let me write the configuration of R6 as well, R5 as well. See, we have one error message here. Duplex mismatch. Duplex mismatch discover on fast Ethernet 0/0. Not half duplex. Let me check which interface is 0/0. On order number 5 0/0. Here I am getting duplex mismatch error. Interface F0/0 duplex full, and on R1 interface F0/1 duplex full. Right. And right. Now on router number 1 or on router number 5, you can verify the border router. So IP OSPF border router. So how many border router are there? 4. Router 4 is ASBR. Router 6 is ABR. Router 3 is ASBR. And router 7 is also ABR. So guys, whatever prefixes we have in area 1, these prefixes, both ABR are going to advertise in area 0. Both routers are going to advertise it in area 0. That means router 5 should perform load balancing. Now wait, let me finish the configuration of router 8 as also. On router number 8, config T interface F 0/0 say no set and IP address. What will be IP here? 68. IP OSPF network .2 point exit interface F1/1 no set and IP address 78. IP OSPF 1. Yeah. Yes, bro. For 1/1. Correct me if I am wrong, brother. IP address 80.1.1.1 255.255.255.0 IP OSPF network point to point. Interface loopback to IP address 80.1.1.2 255.255.255.0. These are LAN networks. IP OSPF network point to point. Done. Now interface range F0/0 F1/0 loopback 1 and loopback 2. On these all interfaces I am going to enable OSPF and will advertise these all interfaces in which area? IP OSPF 1 area 1. And before that, router ID router OSPF 1 and router ID 8.8.8.8. Do clear IP OSPF process yes and router ID 8.8.8. Let me save the configuration. Now see the interesting thing here. So IP interface on which router? 8 na? Yeah, so IP interface brief exclude unassign. Yes. Please check. Oh, interface loopback to IP address 80.1.2 2.1 255.255.255.0 IP OSPF network point to point and IP OSPF 1 area 1. So IP OSPF interface brief done. We have OSPF is enabled on 0/0 only, so IP interface brief exclude unassigned. On this interface f1/1, so run interface f1/1. OSPF network type, OSPF is not enabled over here. Interface f1/1, say IP OSPF 1 area 1. Now router 8 should perform load balancing for external prefixes or not, because router 8 is going to receive external prefixes, means LSA 5 from 2 ABR router, yes or no guys? So IP OSPF database LSA 5, see both ESBR are advertising 3.3.3 4.4.4, but here we are not able to see which ESBR is advertising these, means sharing these LSAs, right? So IP route OSPF, see the routing table. For all external prefixes it is performing load balancing, right? One is via 78.7 means router number 7, and one is 68.6 means router number 6, and cost is 20, which is SID matrix, right? So see, all routers in OSPF domain are using same cost, right? So for external prefixes, cost of our link doesn't matter, yes or no? Cost of our link doesn't matter. Right guys? Now let's say in area 1 I don't want to receive external prefixes, like see the routing table of router 8. See router 8, and this organization is guys very small organization, very small branch offices, right? So this router number 8 is not high configuration router. This router cannot manage the large database of OSPF, because EIGRP is advertising 1000 prefixes, let's suppose, in the OSPF domain, and router 8 don't have capability to handle 1000 number of prefixes. So that's why for this type of scenario we come up with area concept. Clear? Because by default all area like area 0, area 1, backbone area and internal area, both are standard area, and in the standard area all types of LSAs are allowed, right? So to filter the LSAs, let's say in area 1, as I told you, this is a small organization and we don't have high configuration router who can manage the large database or the large routing table. So that's why we come up with area concept. So if someone will ask you why we come up with area concept in OSPF, guys, simply to filter the LSAs. To filter the LSAs. Sometime to filter LSA 3, sometime to filter LSA 5, sometime to filter LSA 1. Right? So now let's begin the area concept in OSPF. Area OSPF areas concept. OSPF uses hierarchical structure with different types of areas for efficiently manage large and complex networks. For the better performance, for the efficient management in the large network, we come up with OSPF area concept. These areas help in controlling the scope of routing information, reducing routing overhead and improving network stability. Like this, a small organization cannot handle lots of prefixes. So we need to filter some LSAs here. So the first type of area is standard area, and all LSAs are allowed in this area. Concept of standard area is a standard area is a regular OSPF area that can accept and propagate inter area and external routes. Means all LSAs from LSA 1 to 5 are allowed in this area. It has fully routing information. So if you have any router in a standard area, that means that router have complete database, complete routing table, right? And before starting the area, let me tell you how many types of areas we have, guys. Here, areas in OSPF. Number one, standard area. Second, stub area. Number three, totally stub area. Number four, NSSA area. Number five, totally NSSA area. We have these area in OSPF. Done. We have these area in OSPF. Right, guys? Any question? No. Any question, guys? If yes, then tell me. If no, then let's move. So first type of area is a standard area, and all LSAs are allowed in this area. That means all routers in the standard area will have complete routing information. Then second area, that is stub area. A stub area is used to filter type 4 and type LSA. Type 4 and type 5 LSA. If you want to filter type 4 and type 5 LSA, simply you can configure that area as stub area. Type 4 and type 5. In stub area, type 4 and type 5 LSAs are not allowed. So in this scenario, as I told you, in this organization, see, this branch office only need to communicate with headquarter, right? This branch office are not going to communicate with this organization. Let's say this is my partner network, partner company, right? This is my branch 1. So branch 1 will not communicate with partner network. Then why branch offices routers are going to install these network information, right, guys? So what I can do, I can configure this area as stub area. Correct? I can configure this area as stub area. Once you will configure this area as stub area, all LSA 4 and 5 will be filtered. Right now, router number 8 have LSA 4 as well as LSA 5 in their database. So IP OSPF database. See the LSA 4. LSA 4. Who is generating LSA 4? ABR routers, right? Why? To share the information of ASBR 3.3 and 4.4.4. To share ASBR information, ABR router is generating LSA 4 and then LSA 5. All ASBR routers are generating LSA 5. I want to filter these two LSA. Simply I can configure this area is as stub area. Command is router OSPF 1 and say area. Which area it is? Area 1. what we can say, stub. That's it. Now remember the OSPF parameters, sorry, hello parameters. Stub must match. So this is why you can see neighborship is not down. So IP OSPF neighbor is down. Stub flag must match. Now when router 8 will send their hello message, it will turn on the stub field, and router 6 and router 7 are sending hello message with stub bit off. So that's why neighborship is down. Now I need to configure stub on router 6 and router 7 as well. So let me take you to router 6, and for now on router number 8 you can see show IP OSPF database. Now in the database, just let me clear the process, clear IP OSPF process, say yes. Just wait for some time. Yes, now you can see show IP OSPF database. Only LSA1 is there, and even LSA1 of router 8 only, right? It is not receiving any LSA from the neighbor because there is no neighborship. So how to troubleshoot this issue? The stub flag should be match, right? So go to R6, and or R6, make sure you are not configuring area 0 as a stub, right? Area 1 is a stub on router number 6. Router 6 is connected with both area router OSPF process ID 1, and say area 1 what stub. Soon OSPF neighborship will come up again. Then router 6 router OSPF 1, area 1 is the stub area. Now go to R8. Now you can see again we have neighborship, and this time if you will check OSPF neighbors database, so IP OSPF database, now you can see LSA4 and LSA5 has filtered, yes or no guys? Now question is how these users are going to communicate with external prefixes. So that's why you can see both ABR router is generating what? Default route. Both ABR are generating default route. So ping will work. Can I ping to 20 network 20.1.1.1 and source 80.1.1.1? Will ping work? Yes, ping will work. Why ping is not working, guys? Why ping is not working? Reply packet, right? Router 2 don't have route for 80 network. So we need to redistribute OSPF into EIGRP. To verify it, simply you can access R2, and on router number 2 we can enable the debugging. Debug IP ICMP, and now let me ping again. See here, this router is receiving ICMP request message, yes or no? Router 2 is receiving OSPF, sorry, ICMP hello, ICMP echo request message. Now to make communication, simply on router number 3 and router number 4 I can redistribute OSPF into EIGRP. So router EIGRP is number 10, and say redistribute OSPF process 1, then metric K value K1, then delay, load, reliability, MTU. Let me copy the command because I'm going to run same command on router number 4 also. Router EIGRP is number 10, and done. Right. Let me write the configuration on R3 also. And now again let me take you to router number 8 and see. This time ping is working, yes or no? Ping is working because of default route. So earlier ABR router was advertising external prefixes in the form of LSA5. But once I have configured this area as stub area, both ABR router have started advertising a default route in stub area, right? So IP OSPF neighborship is full, and so IP OSPF interface F0/0. Let me check the detailed configuration of this interface, and here we can see somewhere about the stub information. Not there. So IP OSPF neighbor, and we can send the neighbor ID. Neighbor ID is 6.6.6.6. See the detailed information of this neighbor. Neighbor 6.6.6 on which interface? Well, IP address of neighbor is this one, and in the area 1 via interface fast ethernet 0/0. Neighborship state is full. There is no DR and BDR. Okay, okay, okay. Dead interval. Okay. So IP OSPF. I think so IP protocol. Or here also you can check the configuration. SPF algorithm executed 3 times. So IP protocol. What it's saying? Stub bit is, guys, what? On. Stub bit is on. Normal means standard area, right? So this router is now stub router, right? On router number 1, if I will run command, same command, so IP protocol, so IP protocol. So you can see here we don't have stub bit 1. This router is in normal area. Clear? So this is an interview question. In the stub area, how routers will get external prefixes? So router will not get external prefixes. Instead of external prefixes, router will get default route, right? This is stub area, first stub area. Stub area is used to filter. Let me write here. Stub area is used to filter LSA 4 and LSA 5. ABR will generate default route in stub area. Clear? We can note configure area 0 as stub to stub area. Backbone area cannot be area stub area, right? So this is the limitation of this area, guys. Backbone area 0 can't be stub area. Otherwise, see, in this scenario, if I will configure area 0 as stub area, then what will happen? What will happen? Headquarter users cannot communicate with external users. right? Because ABR router are going to generate what? Default route. But default route should be towards router number 3 and router number 4, right? So this is the limitation of SBR. And even when you will learn the virtual link concept is also exactly same like extending area 0. To extend area 0, we come up with virtual link. So make sure your virtual link also does not exist in stub area. We can note configure stub area where virtual link exists. These are the concept of stub area. Clear? So sometime you are saying to turn off external LSAs, we are configuring stub area. Actually, what will happen once we will enable stub area on a router, external routing capability will disable on that router, right? Means that router does not support now external routing, right? External routing capability will disable. Then we come up with totally stub area, totally stub, yeah, yes, yes. Why you want to use access list control? Route router OSPF 1 means you want to configure this router as stub for some specific prefix, right? No, 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 you can't. Area 1 stub and this C. We don't have any option, right? Only we can configure this non-stub, totally stub area. This is how we can configure totally stub area. Here we cannot apply it with ACL. So if you know these prefixes, see in the real time you will have brother lots of prefixes, thousand number of prefixes. And like this, let's suppose you have 100 branch or thousand number of branch. So on all thousand number of branches, you are going to configure ACL for all 100 prefixes. Hmm? Okay, then you can. If you can, but see now this is not practical. It's look like impractical, and even whenever we will add a new branch here, then again I have to apply ACL on all branch offices router, yes or no, on all ABR routers. Yeah, time consuming, and every time when we are going to add the network or we are going to remove the network in the partner network company, then you have to modify the ACL. By the way, for route filtering, we will never use access control list. For route filtering, we have what, guys? Distribute list. There we are just using ACL to match the traffic. Anything else, bro? Okay. Can I move? See, the another limitation of stub area is ESBR cannot exist in stub area. ESBR is not allowed in stub area. This is also one limitation because ESBR is generating what? LSA 5, and you are filtering LSA 5. So that's why I told you in this scenario area 0 should not be a stub area. Now the issue is, see on order number 8. On order number 8, I have filtered LSA4 and LSA5, so IP OSPF database. Still the size of database is large. We have lots of LSAs, LSA3 here, right? So if you want to filter LSA3 also, like LSA4, LSA5 and LSA3, then you can configure this area as totally stub area. So totally stub area is used to filter LSA3, 4, 5. It is used to filter LSA3, LSA4 and LSA5. Done. So let's suppose here now I want to filter LSA3 as well. So simply I can say router OSPF 1 and area 1 stub and then no summary. No summary means don't advertise summary LSA as well. No summary. Done. So IP OSPF neighbor and so IP OSPF database. Still we have LSA3. So now I am going to configure totally stub area on order 6 and order number 7, and on order number 8 I need to actually remove one command as well. Config t router OSPF 1 and do so run section OSPF C. On this router I have configured this router as totally stub area. Okay, fine. Go to router number 6 and say area 1 stub and no summary. No summary. On router number 7 also say area 1 and no stub, no summary. Now go to router number 8 and check the routing table, sorry, database table. So IP OSPF database. Now you can see the database size. Now see, so in the totally stub area, EBR router will only generate default route. Here I have filtered LSA3, LSA4 and LSA5. All LSAs are filtered. Even I can ping to 20.1.1.1. Ping 20.1.1.1 source 80.1.1.1. See, ping is working. But the key point is you need to remember that backbone area should not be configured as stub or totally stub, and ASBR are not allowed in stub area and in the totally stub area as well. The rest configurations are same. See, stub area and totally stub area both are same. The difference is stub area only filtered LSA4 and LSA5 and totally stub area filtered LSA1, LSA3, LSA4 and LSA5. Then yeah, it is performing. There are two ASBR, two ABR, na? So IP OSPF database. Both are generating default route. Right? So IP route OSPF. It is performing load balancing. Done. Now see, in the stub area ASBR is not allowed. That's why we come up with NSSA area. So again NSSA area is used to filter LSA4 and LSA5, but ASBR are allowed. LSA4 and LSA5, but here ASBR are allowed. Then we have what? Totally NSSA area. Again, totally NSSA area is used to filter LSA3, LSA4 and LSA5. 5. In this scenario, in NSSA area, how routers will get route? So ESVR router will generate what? Default route. ESVR will generate default route. In the form of LSA 7, because LSA 4 is not allowed here, LSA 3 is also not allowed here. So in the form of LSA 7. See on router number 8, you have filtered the LSA 345, so IP OSPF database. This time on router number 8, okay, we have some LSA. Okay, here area is stub area. Stub area or totally stub area? An SSA area is used to filter LSA 4 and LSA 5. That is correct. And ESBR is allowed here. Correct. And ESBR is going to generate ESBR. Both ESBR will generate default route in the form of LSA 7. So here external prefixes in OSPF domain. Yes. So if I will configure this area, what happened? This area, what happened? My pen is, this area as an SSA area. Then how these routers are going to get default route, guys? Because LSA 3 is also not allowed. So right now, router 6 and router 7, these two routers are ABR router, correct? So IP OSPF border router. These are ABR router. But once I will configure this area as NSSA area, these two routers will start acting as ESBR. And it will generate LSA 7. It will generate LSA 7. See, router OSPF, router OSPF 1, say no area 1 stub, right? And now I'm saying area 1 NSSA. NSSA, no summary, means totally NSSA. Then go to router number 6, and here also say no area 1 stub, and then area 1 NSSA, no summary. Router 7, no area 1 stub, and area 1 NSSA, no summary. Now go to router number 8 and check the database. So IP OSPF database. These routers are now ABR as well as ESBR. These routers are ABR as well as ESBR. So IP OSPF database. Clear IP OSPF process. summary LSA. Here still we have that error on F0/1. Now I am getting this error message on F0/1. Let me fix it first. Interface F1/0/1 and duplex. Interface F0/1 is not there. On 0/1, how I am getting this error on 0/? Do so IP interface brief. 0/1 is not there, right? No, here I am getting this error message CDP duplex interface F0/0 no CDP, no CDP enable. On R1 also interface F0/1 say no CDP enable, right? So IP OSPF database. LSA 5, LSA 3, LSA 1, but on router number 8 we should have LSA 7 as well. What I am missing here? Router 5, router OSPF process ID 1 and area 1 NSSA and default information originate. I think I have to run this command here. Yes, now you can see LSA 7. You have to run this command on your EBR. But before this, how LSA 3 are there in the database of router 8? Because this is totally NSSA area. So run section OSPF LSA 3 is not allowed here, so IP OSPF database. How LSA 3 is there? By the way, we have to run this command, guys, on ABR router, right? Then only my router will advertise default route in the form of LSA 7. Default route in the form of LSA 7. Let me do one thing. Let me remove this command and once let me clear the OSPF process here. Clear IP OSPF process because I am getting some wrong output here on router number 8. So IP OSPF database. Still we have LSA 3 here, and so run section OSPF. Fine. So run section OSPF. So run section OSPF NSSA. That is correct. Actually, this ABR router is converting ABR routers are converting LSAs. So on the ABR router, to generate default route in the form of LSA 7, see here you are able to see LSA 3 in this area, but on real devices you will not have LSA 3 because this is totally stub or totally NSSE area where LSA 3 is not allowed. So how you will receive the prefixes? You have to tell to your ABR router to generate a default route, right? So where LSA 3 are not allowed, or LSA 3, 4, 5, these LSAs are not allowed. In that area, how router will generate default route in the form of LSA 7. So guys, we have LSA 7 for NSSA area only. For NSSA area only, where LSA 3 is not allowed. Where LSA 3 is not allowed. Let me check this PDF here. Standard area, stub area. So concept of stub area is, you can see a area. A stub area is an OSPF area that does not accept external route, means LSA 5, even LSA 4. Instead, a default route is used to represent any external networks. This simplifies the routing table and reduce the amount of routing information within the area. Example, a retail company with multiple branch offices. Each branch would be configured as a stub router. These branches don't need to know the specific external routes, so a single default route points to all non-local traffic towards the headquarter. Fine. Totally stub area concept. A totally stub area goes to a step further than a stub area by blocking both external LSA, means LSA 5, and inter area routes, means LSA 3. It only accepts intra-area routes and default route. Example, a university network, the administrative department might be configured as totally a stub area. The department only need to reach the core network for essential services and does not require detailed routing information to the other areas. Then NSSA area. The concept of NSSA area is, an NSSA area is typically a type of stub area that allow for limited external routing. It can import external route in the form of LSA 7 into the area, then convert them into LSA 5 with their to the backbone area. This is useful area for area that need to connect the external networks. Definitely working fine. A finance firm, this is the example like where we should use it, and totally stub area which will filter LSA 3 and LSA 5. So here in the totally stub area we have filtered the LSA 3 and LSA 5. Fine. Stub area only filter LSA 5 and LSA 4. Totally stub area filter LSA 3 as well as LSA 5. But here see, I am able to see the LSA 3 in even NSSA area. So this is error of simulation only, guys. We can ignore it, right? In the real time, in a totally NSSA area or totally NSSA area, you will not have LSA 3. And to receive external prefixes or default route for the external prefixes, we can run this command on ABR router, so that ABR router will generate default route. Router OSPF 1 and say area 1 NSSA, and then default information originate. Default information originate. Now it will generate one default route in the form of LSA 7, right? Now why router 7 is not generating default route? Because here I have not configured that command. So router OSPF 1 and area 1 NSSA, or is there anything wrong, guys, in configuration? That can be also possibility. So you can check it. Default information originate. Now we are getting default route from both ABR router, right, in the form of LSA 7, and so IP OSPF border router. Now my ABR router are acting as ESBR router as well. Now ABR router will start sending default route in the form of LSA 7. So what is the use of LSA 7? To advertise default route in NSSA, totally NSSA area, or in the NSSA area you can say. NSSA area filter LSA 4 and 5, and totally NSSA area filter LSA 3, LSA 4, LSA 5. Yes, bro. So IP route OSPF. Done. So stub area filter. See, first of all, standard area allowed all LSAs. Stub area filter LSA 4 and 5. Totally stub area filter LSA 3, 4, 5. NSSA area filter LSA 4 and 5 again, but ESBR is allowed there. And totally NSSA area filter 3, 4, 5, LSA 3, 4, 5, and ABR order will start sending default route in the form of LSA 7. But all router in this area have full knowledge of the entire OSPF domain. They can see the intra area, inter area, and external routes. This area acts as central hub where all other routers areas are connected. It has most detailed routing information. Stub area. You can read these notes. This is important, like real-time example for each area. Then there is a concept of forward address, guys. See, ABR router with higher router ID will convert LSA 7 into LSA 5, and ABR router will start acting as ESBR. Actually, this is the main concept here. ABR with higher router ID will only convert LSA 5 into LSA 7. Sorry, LSA 7 into LSA 5. LSA 7 into LSA 5. I will check this configuration here in this area, in area 1, in this small organization, and we'll continue it from the tomorrow. There is, I think, some misconfiguration on, or it can be because of simulation software. So don't worry, I will check it after the class or maybe tomorrow morning. Then we'll move further, guys. Okay. Then we have concept of forward address in OSPF. After that, there is nothing in OSPF again. So we will see the route filtering, path manipulation, and one more thing we can discuss, that is network type. Then virtual link is there, so we'll cover the virtual link as well. Okay, so only virtual link is there in OSPF. Virtual link is pending in OSPF. Done. So any question from the today's session? Today we have covered LSA 5. We have seen the ESBR configuration, multiple matrix types while redistributing external prefixes in OSPF. Right, and here my scenario is not working fine. My configuration is not working properly. So I will check this configuration. So what I am going to do, I am going to save this configuration so that I will verify it. Router 6 and router 7. Done. Turn off the devices. Yes, guys.